All right, question 10. Evaluate the integral from -8 to 8 of 8 minus absolute value x. Well, graph it. And this one might, be one that you are not super familiar with, and that's okay. Put it on your calculator if you need to. But remember, absolute value is a V shape. Absolute value is a V shape. And in this particular case, it's going to open down. And it's going to cross the y-axis at 8. So we're going to have a shape, something like this. And again, it doesn't need to be super exact. Okay, it doesn't. Now, what we're really interested in is what happens at these 8s. So what I'm going to do is I'm just going to look at 8 minus the absolute value of -8, just to see where we're at. I mean, I don't know. This is important because it's our bottom left endpoint. So this is going to end up being 8 minus 8, which is 0. So right here is -8. And we're going to use our knowledge of absolute values to say right here is +8. Okay? So what do we want? We want area under the curve. What kind of curve do we have here? Hey, we have us a triangle. All right, figure out your base. Triangle, area of a triangle, 1/2 base times height. Lucky us, it's just one triangle, and we can find that height. The height right here at 0, when you do that, 8 minus 0 is 8. So my height in this case is 8. My base right here is 8, and my base right here is 8. So base equals 16, height equals 8. So how do I evaluate the area, or how do I evaluate this integral? I look at the area of the triangle that represents the graph shown. So 1/2 times 8 times 16, which is going to be 64. And there you go. This integral would be equal to 64. All right, this guy's just a little bit different. Why? Because we're not stopping at a specific spot. We're saying the integral from 0 to b of 6x dx, where b is greater than 0. What now? Draw the graph. So we can draw the graph of 6x. Let's just get it going here real quick. And again, as with all these graphs, they don't need to be super accurate. They just need to be real rough sketches. So here we go. Here's this guy, 6x right there. And what are we talking about? We're talking about the integral from 0 to b. The integral from 0 to b. Well, how do I evaluate that integral? I find the area under the shape, which is a triangle. So this area is going to be 1/2 base times height. My base in this case starts at 0 and goes all the way out here to b. So my base is b. The height of this particular guy starts right here at b and goes all the way up to my line. Now, where's the height of my line? It's right here, and it's the function at b, which in this case is going to be 6 times b. So my height then is 6b. So what would the integral equal? My integral is going to equal 1/2 times the base times the height, or 3b squared. All right, here's another one. Even a little bit more tricky than the previous. The integral from a to 3a of x dx. And again, it's tricky because where a and 3a are, we've been using numbers. So what do we do now? Well, the same thing we've done on every problem through this little stretch on the review. Graph it. We can graph the line y equals x. In fact, it's one of the easiest graphs that we should be able to reproduce without issue, and almost identical to what it should actually for reals look like. Now, the one thing they're telling us is that a has to be larger than 0, which means then that we're just going to look at the positive side of the x-axis. Okay, so here's my line, y equals x. All right, here it is, y equals x. Now, it tells us we're going to start at a and stop at 3a. So here's a, here's 3a, Now the question is, what do we do? Well, we evaluate the integral. Why? How? What? Well, you can evaluate an integral by finding the area under the curve. And in this case, we have the shape of a trapezoid. Shape of a trapezoid means we use the area formula of 1/2 height times base 1 plus base 2. There's your area of your trapezoid. And that's the shape that we've got. So the distance from A to 3A, that's my height, because if we were to tip this guy over so that the bases are parallel this way horizontally instead of vertically, it would be a little easier to see. That would be the height. The bases then are just going to be the distances from the x-axis to that point on the curve. So here would be base 1 and that point on the curve to the x-axis. This is base 2. And it's just like all of the other problems that we've looked at through this section. How high are we? How high off the x-axis do we get? How far up the y-axis do we get? Well, if you look, this point right here goes through f of a, and this point right here goes through f of 3a. What does that mean for us? Well, look at your function in here. It's the function y equals x. So if I need f of a, then I replace x with a. And if I need f of 3a, then I replace x with 3a. Well, what about my height? My height is going to be stop minus start. So my height on this particular guy is going to end up being 3a minus a, or 2a. Now I've got all the pieces to fill into my area formula. And am I going to have a variable in the answer? I am. But we are big kids. We can handle this, okay? We can get through this together. So 1/2 times the height times base 1 plus base 2. So simplify this guy out. This is going to be a times 4a. And that's going to be 4a squared. And that is the area of the trapezoid created by the shape of the line y equals x from a to 3a. It also is the answer to the definite integral from a to 3 of x dx. And that answer is 4a squared.